The fixed bias configuration of the figure has an operating point defined by VGSQ is equal to -2 volt, IDQ is equal to 5.625 milliampere with IDSS is equal to 10 milliampere and VP is equal to -8 volt. The network is shown in the figure with an applied signal of Vi. The value of YOS is provided as 40 microsiemens. So A part determine GM, B part find RD, C part determine ZI, D part calculate Z0, E part determine the voltage gain AV, determine F part determine the voltage gain AV, ignoring the effects of RD. Okay, so the figure, you know that it is a fixed bias configuration. So what is this resistance? That is RG and this is RD, right? So how will you draw the AC equivalent model of a fixed bias configuration? Okay, so in your input, first you are going to replace your JFET by means of its equivalent AC equivalent model. Okay, so you know that the input impedance is open, right? And in the output you have your voltage controlled current source, that is GM into VGS, and the output impedance, that is denoted as RD, right? So this is going to be your drain, this is going to be your gate. So the input voltage is given as VGS, right? And this is going to be your source. Source is grounded. Okay, so in the network, so when you draw the AC equivalent model, you will be shorting your capacitors and you will be shorting, that is your DC will be equal to 0. So this also will go to ground. Here VG also will go to ground. Okay, so the RG will be directly going to the ground. So in the network, what do you have? In the across the input side, you have your resistor RG that is going to the ground, and across your output you have your resistor RD that is going to the ground. Okay, so this is in short your AC equivalent model. So from the AC equivalent model, you are going to find out the value for Z0, then ZI, GM, all those things, right? So let me write directly, let me go to the first equation, find out GM. So what is meant by GM? GM is nothing but the trans conductance. So what is your GM value? GM value is given by GM0 into 1 minus VGSQ divided by VP, pinch of voltage VP. Now what is your GM0? GM0 is the value of trans conductance or value of GM when VGS is equal to 0, right? It is given by 2 IDSS divided by magnitude of VP, right? So once you know GM0, you can calculate GM. So the first formula is done. Second one, you have to find out your RD, that is your resistance RD, which is nothing but your output impedance, right? You have a clue given in your question, YOS is equal to 40 microsiemens. So what is your RD? It is nothing but YOS is nothing but your admittance, right? Admittance, and O represents your output and S represents your source terminal. Okay, so you know that your admittance, output admittance YOS is equal to 1 by output impedance, right? So I can write that RD is equal to 1 by YOS directly. Next, third one, find out the value for ZI. So by seeing the circuit, you know that input impedance is equal to your resistance RG directly, right? And D part, what is your output impedance? Z0. Z0, you know that if you want to find out the output impedance, your input should be kept as 0. When the input is kept as 0, VGS will be equal to 0. So you will be having your resistance small rd parallel to that of your capital RD. Next, E part, your voltage gain is equal to minus, you have 180-degree phase shift, right? So you have minus GM into RD parallel to small rd, right? And F part, if you have to ignore the value for small rd, then AV is equal to minus GM into capital RD. So these are the formulas which you have to apply. Let us go directly to the problem now. So first let me take your A part. So first you are going to find out what is your GM0. GM0 is equal to 2 IDSS divided by magnitude of VP, right? 2 into what is given in your problem, IDSS is equal to 10 milliampere, right? 10 milliampere divided by magnitude of VP is equal to minus 8. So here it is magnitude, so you will be getting 8, right? 8 volt. which is equal to, you will be getting 2.4 millisiemens, right? And what is your GM? GM is equal to GM naught into 1 minus VGSQ divided by VP. Okay, so what is your value? GM naught 2.5 millisiemens into 1 minus VGSQ is what? VGSQ is equal to minus 2 volt, right? Minus 2 volt divided by your VP is equal to minus 8 volt. Okay, so after the calculation, you will be getting GM will be equal to 1.88 millisiemens, right? So GM you have got. Now B part, you have to find out what is your RD. RD you can write directly the equation 1 by YOS, which is equal to 1 by 40 microsiemens, which is equal to, you will be getting it as 25 kilo ohm. So small RD you have got 25 kilo ohm. Now ZI will be equal to capital RG. So capital RG is given in your problem. So it is equal to 1 mega ohm. And D part, you have to find out the output impedance. You know that output impedance is parallel combination of your two resistors, that is RD and small rd. So you will be getting what is capital RD. It is equal to 2 kilo ohm, which is given in your problem, right? RD is equal to 2 kilo ohm parallel to small rd. Already you have calculated 25 kilo ohm divided by RD plus RD. So 2 kilo ohm plus 25 kilo ohm. Okay. Oh, sorry. Parallel combination. Now let me write the formula. So what will be this? Z0 will be equal to 2 kilo ohm into 25 kilo ohm divided by 2 kilo ohm plus 25 kilo ohm, right? So what you will be getting? Approximately you will be getting 50 into 10 raised to 6 divided by 27 into 10 raised to 3. So after calculation you will be getting Z0 is equal to 1.85 kilo ohm. So you have got the value for Z0 also, that is D part. Now E part, you have to calculate what is your gain. Gain is given by minus GM into capital RD parallel to small rd. So what is your GM? You have calculated 1.88 millisiemens, right? So 1 minus 1.88 millisiemens. Already you have calculated the value for capital RD parallel to capital RD. So you know that it is equal to 1.85 kilo ohm, right? So you will be getting AV will be equal to minus 3.48. Okay, this is with the inclusion of your small rd. Now F part, you have to calculate AV without neglecting the value for rd, right? So you will be getting AV will be equal to minus GM into capital RD. So again you have minus 1.88 millisiemens into what is your capital RD? 2 kilo, right? Yeah, 2 kilo. So AV will be equal to minus 3.76. So these are the different values you have got. So you have got GM is equal to 1.88 millisiemens, then RD is equal to 25 kilo ohm, ZI is equal to 1 mega ohm, Z0 is equal to 1.85 kilo ohm, and AV is equal to minus 3.48 with RD, and AV is equal to minus 3.76 without RD.